Alright, so let's take a look at this very basic example. The example is the sum. Often people leave out these sums. For most of the series it starts off at 1 and goes to infinity. Sometimes they start off at 2 or 3 just to avoid zeros on the denominator. That part's not that really interesting. After all, only the tail matters. The first 5 gazillion terms will still be finite. Again, assuming you've got real numbers here. In any case, here's the strategy for the limit comparison test. We're first try to sniff this out and see, what does it smell like? Okay, that's going to be the first step. Once we figure out what it smells like, we're going to try to verify our, do a second little test to make sure that we did the first step correctly, that we've got the right sequence, and to do that we're going to take the limit. We're going to check that one of them, at least the top or the bottom, is a positive, and then if we do that, we will be able to declare that the one we've had, the series we have, is the same as the one we think it smells like. Here I'm already revealing what I think it's going to smell like. So here we go. Let's do it. Talk is cheap. So the first thing is, what do you think? What do I think it smells like? I hate that white line. All right. So to do that, here's what I'm thinking. On the top, I think I'm going to go with. I'm going to think in green today. So on the top, I'm thinking that 3 plus n, well, the 3 really doesn't matter. And on the bottom, I'm thinking I've got 8 minus 5n squared. I'm thinking that the 8 really doesn't matter that much. I'm thinking that this looks roughly like an n over negative 5n squared. And I could simplify that. I could say this is equal to 1 over negative 5n. And of course, the negative 5 is not going to matter that much. I can think maybe that, you know what, I think that it just behaves a lot like 1 over n. All that is just the smelling part. You think, hey, I think that the 3 doesn't matter. I think that the 5 doesn't matter. I think that the 8 doesn't matter. I think really it behaves a lot like 1 over n. So the first step, what does it smell like? I think it smells like 1 over n. Okay. Second step, can I verify? Well, I would need to check this limit divided by that. I would need to check the limit of my 3 plus n over 8 minus 5n squared over 1 over n. I need to check this limit, the one I've got and the one I think it smells like. And I need to check that this is equal to some constant. That's this step right here. And then the next step, I need to check that I'm not doing some crazy stuff here. I need to check that at least one of them, one of the series is positive. The one I think it smells like, 1 over n, is positive. So that checks that one. All I need is one of these, and that would check that. All I need now is to figure out this limit, and then we can declare this one to be similar in its behavior as the series, corresponding series for that one. That one's famous, by the way. It's called the harmonic series. Everybody knows it diverges by the integral test, for example. Alright, talk is cheap. Let's do it. Got it? Alright, so we first smelled it out, and we think that it smells like, we think that 3 plus n over 8 minus 5n squared, we think that smells a lot like 1 over n. So we're going to check out this limit as n goes towards infinity. Do a little cleanup here. Maybe do 3n plus n squared all over 8 minus n squared. That's algebra. And then of course I could still do some more algebra. I could do 3 plus 1 over n over 8 over n squared minus, well, I think I forgot the 5, minus 5. So divided this by n squared, divided that by n squared, divided this by n squared, divided that by n squared. I multiply, basically I multiply top and bottom by a 1 over n squared, 1 over n squared. That helped me simplify into this, and now I'm ready for my limit business here. Limit as n goes towards infinity. That would give me, of course, 0 plus 1 all over 0 minus 5, which is equal to negative 1/5. Yippee-ki-yay. This verifies that it's a constant, a non-zero constant. That helps me verify the smell test, and of course I already talked about this. It's one of the sequences. That one is positive, so we're good. And I should maybe point out something in case you're reading other books or websites or other videos or whatever. They don't always write it this way. A lot of other people will have you that will require that both an and bn are positive. The reason is that they do that is because they've never learned any better. You really don't need that. All you need is one of them. That's why they pay me, yippee-ki-yay. Otherwise you couldn't apply that test here because one of them is negative. At least not with some running around stuff. Alright, at least you couldn't apply it in a straight way. Alright, so anyways, so we've verified our two conditions, that the quotient, this limit is a constant and one of them is positive. That's it. Then we get to the good part. The good part would be that we can declare, let's go to the good part here. Well, it was all good, right? Based on us verifying this step and that step, we can declare that these two are similar. Now this one, of course, diverges by P-series test. It's famous. Or if it's not famous for you, you need to make it famous for yourself and maybe do an integral test on that, so you can become famous for you. Therefore, from there you can conclude that the summation of 3 plus n all over 8 minus 5n squared diverges by limit comparison test, comparing it to 1 over n. That's it. Very nice example. It's not very hard, but it shows you exactly the right steps, the right way of thinking about the limit comparison test. Alright, come back for another example. See you guys.